Another application of differential equations is using them to find both slope and right tangent lines and make approximations from there. So I want to show you two problems that I pulled directly from Delta Math, and you're going to have to then do some of your own problems. You might see something very, very similar to this, and hopefully this will help. So what they'll do is they'll give you a differential equation, and it's going to look different than what you're used to. You're used to just having like dy dx and then just a bunch of x's, but you're going to notice that this derivative is going to be in terms of both x's and y's, very similar to things that we saw when we did implicit differentiation at the end. They're going to give you an initial condition, so that's your point that you're going to use to find slope, and then they're going to ask you to write a tangent line equation using that point and slope to make an approximation. So here's how it works. So first I need slope, which is going to come from plugging your x and y, so your 1 and your 4, into this derivative equation. So when we put 1 and 4 in, we get 4 squared over 1. We get a slope of 16. Your slopes can be any number, positive or negative, whole number or fraction. Then we're going to take that slope and the given point, and we're going to write a point slope formula. So y minus your y value equals your slope times x minus your x value. You do not have to simplify this. And then you're going to finally use that tangent line to make a prediction about the function. So a tangent line is going to model very well the equation right around where that point of tangency exists. So it's asking you to make an approximation at 0.9, which is really close to 1. So it should be a really good approximation. So we're going to put 0.9 in where you see x. So you're going to have 16 times 0.9 minus 1. And if you need to use a calculator, you can. 0.9 minus 1 is negative 0.1 times 16 would be negative 1.6. And then we're going to add 4 to both sides. So we get our final answer to be 4 minus 1.6, which is 2.4. All you're going to have to type in Delta Math is going to be your approximation. So this numeric answer. So your approximation is about 2.4, and you're going to type it in as you see it. Let me show you one more just to make sure you're comfortable with this type of presentation. So again, you get a differential equation, a derivative equation. You're given a point, so you're going to plug in your x and your y into that equation. So your slope is going to be 2 cubed over 3 plus negative 2, which is 8 over 1. So we get a slope of 8. Then we're going to write our tangent line. So y minus y equals a slope of 8 times x minus a minus is going to be plus 2. We do not need to simplify that. We can plug in our x value that we're asked to do an approximation with. So we're going to put negative 2.2. You'll notice you're always asked to make an approximation close to the actual x value you have. So our x value is negative 2. This is negative 2.2. So we get negative 2.2 plus 2, which would be negative 0.2. Times 8 would be negative 1.6. And again, if you need a calculator for the arithmetic, they try to stick with pretty basic numbers. And then we're going to add 2 to both sides. So we get 2 minus 1.6, which will be 0.4. And that is what you're typing in. So that's how we use a differential equation, an equation of a derivative, in order to take a point and write a tangent line, and then use that tangent line to make a prediction on a different x value.